In this segment, we're going to go over serializing JSON with the Kafka producer. So what I have here is a project that has this Kafka JSON demo, a JSON encoder, and a decoder. Let's walk through this. So remember, when it comes down to it and data goes across the wire, Kafka producer is going to end up sending a byte array. So it's a byte array for the keys and a byte array for the value. And I should really say a byte array for the key, not the keys. So the key is a byte array and the value is a byte array. Now, perhaps you have an application where you're passing JSON around and you don't want to end up having to convert that JSON to a byte array all the time in your code. Looks messy, may not be as clean or elegant as you want. So what you could do is you could implement the encoder interface. So here I have this JSON encoder. I'm going to use a Jackson object mapper. You could use any JSON library you want. It really doesn't matter. I chose to use Jackson in this case. It's going to take verifiable properties that must be present just for implementing this interface and what the constructor needs. And then you have this 2bytes method. It's going to take in an object. And in this case, I'm just going to turn around. I'm going to write the value as a string and get the bytes. Now, obviously, this may not be JSON. So we have this exception that may occur. Print the stack trace, and we end up producing an empty message. May not be exactly how you want to handle error conditions. It's purely just an example. The key is this 2bytes method that takes an object, returns a byte array. The way that we'll use this is in our producer setup. And again, this could be a config file, your environment, or in code. You'd have the serializer class and you put the fully qualified class name of that class. In my case, there's no package name. It's just right here, JSON encoder. If it was a separate jar, again, the fully qualified name, and you'd want to have the jar on the path. When this is set up, and I now call this producer record, and I call send, what's going to end up happening is the Kafka producer will end up calling the 2bytes method on my encoder. So now I could go ahead and I could just pass this JSON object in to the producer all the time. Okay, so say for instance, this was happening somewhere else in my code, and this is all set up. I could just be passing in JSON and not worrying about it. My encoder will take care of it. Now there's going to be times when you're going to want to read the data and it's in JSON. You have two choices there. Since you're going to get back a byte array where you're consuming data from Kafka, you could in turn just convert it to a JSON object. Or you could use the decoder where you would do the opposite from bytes and you go ahead and decode it. Again, returning an object. So a very similar way, you got the encoding going in, the decoding coming out. So that is how you could work with JSON using Kafka Producer and the consumer. In this segment, we're going to discuss configuring serialization and deserialization in Apache Kafka with Avro. There's no built-in Avro serializer and deserializer with Kafka, but you have a couple of options. Most likely you're considering using Avro because of the schema support that it provides, and probably in particular the schema evolution, which is a fantastic feature of Avro where you could evolve schemas of the data as your data changes, as your business changes. If that's the case, perhaps an option, maybe one of the best options at this time for you, is to use the Confluent IO platform, which provides Avro serializers and a schema registry that satisfies most likely all the needs you'll have for schema evolution. So that's one way to go. If you went that route, here is where you'd find the documentation under application development where you could configure for the serializer the Confluent Kafka serializer's Kafka Avro serializer, and you'd have the same thing for a deserializer, where it would be Kafka Avro deserializer. If you use those, serializer and deserializer, it will allow you to pass in Avro data that you have in hand to the producer directly and allow the consumer to deserialize what Kafka returns as a byte array to Avro data and give it back to you. This handles all interaction with the schema registry and everything to do with decoding Avro data to a byte array and basically reversing a byte array into Avro data. And all you would do with this is you include these dependencies, and again, the versions may change by the time you're going to use this, so make sure you do check to see if it's updated. And then you set up some properties that you want the serializer class to be the Kafka Avro serializer, and you want the value to be the serializer. And you set up the schema registry URL. That really is it. And once your producer is set, then it's really as simple as sending data. Okay, so here's an example they have. You have this user, which may be a Java Pojo that you have that's in Avro. You set the name. You call producer send with that user. That's it. It couldn't be any simpler. If this does not meet your needs, and you have another reason for using Avro, maybe your schema is a fix, maybe you don't need the evolution or the registry, then similar to what we did with our JSON encoding and decoding, you could just use Avro decoder and an Avro encoder. Either way, you have choices of using the Confluent IO platform or building your own encoder and decoder. In this segment, we're going to discuss configuring compression for Apache Kafka and for the producer specifically. There are two configuration settings that drive compression for the producer. The first is a compression codec. The default for this is none. The options are gzip, snappy, or LZ4, or none as a default. And you could also use old config values 0, 1, 2, 3 instead of the text. If this is set, this will allow that type of compression for all topics. To control it on a topic by topic basis, then you could have set the compressed topics property. This will be a comma separated list of the topics that you want to compress. This also assumes that the compression codec is not set to none. So if you set the compression codec to perhaps gzip, and then you had a compressed topics list set, so let's say if we did this, if we had this to be, say topic A, topic B, and then here we had gzip, then we would be telling the producer that we want topic A and topic B compressed with the gzip algorithm. If this is mistakenly left as none, then there's no compression that will happen here. And if we set it like this, and this is commented out, so it's ineffective, then again, that would be gzip compression for all topics. If you use the new Kafka producer, which is not yet considered production ready, instead of codec, it has type, okay? And the values are the same. Same options. None, gzip, snappy, LZ4. That is how you configure compression with the Kafka producer. In this segment, we're going to go over adding a consumer to a Kafka cluster. Now, I already have a broker running and Zookeeper running. And the first thing I'm going to do is I'm going to go ahead and create a topic that we're going to use. So we're going to create this topic here. Just copy this over real quick. we're going to create a topic called consumer test. It's going to have one partition, okay, and replication factor of 1. Okay, we got that created. Now what I'm going to do is I'm going to go ahead and I'm going to start up a consumer. In fact, I'm going to start up 2 consumers. So let's do console consumer. Okay, we give it zookeeper, host, 2181, and the topic is going to be consumer test. Okay, so that consumer going. Let's go to the next tab here. Let's copy and paste this, make our life easier. Okay, in this next window here, we're going to start up another consumer. Okay, so we have 2 consumers going. Let's go over here and let's go ahead and create a producer. There we go. So I got this producer here, and we're going to produce to consumer test. Okay, so again, it's producer, it's got broker list as local host, and the topic is consumer test. Okay, producer's up and running. Okay, our consumers are there. They've done nothing yet. So let's go ahead and say, hi there, consumers. Okay, this consumer got it, and that consumer got it. So in this case, both consumers got the same message. So let's look at that again. So here is another message. Again, both of them got it. So here's the key point. Even though we had created a topic with one partition, both of our consumers got the message. Now, one thing to point out here is that the level of parallelism with Kafka and the consumption is the partition. So the consumers are in a consumer group, and each consumer group gets to read the whole topic, and each consumer thread, each consumer reads a partition. So in this case, since both of our consumers are getting these messages, they must be in different consumer groups, right? Because our topic is one partition, which should mean only one consumer can read it. Let's go ahead and stop one of these consumers. Okay, and let's take a look. Let's convince ourselves of this. Let's take a look at the consumer config. Okay, so if we look at this, we'll see, besides the zookeeper information, here's an important thing. Group ID test consumer group. Okay, so if we start up both consumers and point them at this config, then we should have 2 consumers in a consumer group trying to read a topic with one partition, so only one of them should get the data. So let's go ahead and test that out. Okay, so we're going to say here that this is going to go to consumer config, and it's going to be conf. Oh, that was supposed to config. Okay, so we're going to start up that way. Okay, that's starting. Let's go here. Let's kill this one and do the same thing. Consumer config. Okay, we'll start up. Now you notice we got this warning here. No broker partitions consumed by this consumer thread. Okay, so it's already warning us that we have a consumer. This may not consume data. This one has no errors. Okay, let's go ahead and write another message. Hello, consumer group. Okay, they'll start to figure it out. They're trying to balance who gets what, and the message will eventually pop out with that consumer. Let's try again. Hello again. Okay, we can see that now this one consumer is getting the messages. Okay, and this one got nothing. Okay, so we do it again. Hi consumer 1, nothing. Hi consumer 1. So this in fact shows, right, that we have 2 consumers trying to consume from a topic that has one partition. So only one consumer gets to see the data. So in your applications, when you go to add consumers, if they're in the same consumer group, you want to only have the same number of consumers as you do partitions. Otherwise, in the case of this, we have an application running that's never going to see data. Okay, if we do it again, hello again. Same thing, right? So this application is running, never sees data. This one does. Now, a nice thing, the consumer group is what sees all the data. Okay, so that's the guarantee from Kafka, is a consumer group will consume a topic its entirety. So what's nice is that if, say, for instance, we had a problem with our software and it crashed. So let's go ahead and kill this consumer. Okay, it's gone. This consumer doesn't know anything about it. It's part of the group. And let's just say, hello consumer 2. Okay, boom, there's data. So they rebalance, they're part of the group. All of a sudden, this other consumer was able to start reading the data. If we start this consumer back up, we fix whatever bug it may have been, you can see now that this one's not going to get data. Okay, hello consumer 2 again. So trying to figure it out, because there's a new assignment, data is going to end up there. Okay, and we'll end up with the data coming to that second thread. So the key point is, when you add consumers, you add them to the same consumer group, that you want to have the same number of consumers as you do partitions of the topic you're reading. If you have more consumers than partitions, you're going to have consumers that are never reading data. So we see the data got to this one and never to this one that we started up second. Okay. If you start consumers in different consumer groups, then they could continue to read the data. But the key thing, again, a consumer per partition. And you could add consumers to a group as often as you want. You could add them, take them away. It's the group that reads the topic. In later segments, we'll go over using the API in more detail. For now, we just use the shell scripts to show how this works. In this segment, we're going to talk about some of the Kafka testing utilities that exist in the code base that you could use to make your testing with Kafka producers and consumers much easier. Now again, this is not the end all be all. You could easily do something similar, but this is a great start. So let's first start with using a mock producer. So I'll go ahead and set these properties. Really don't need them in this case, so I probably could just do this. Just get rid of those. Okay, so there's a mock producer which doesn't care about them. So I can go ahead and create this mock producer. True, as we'll see, and we'll go over the source code for that in a moment, tells it whether or not to auto-complete. We go ahead and create the record, just like we normally would. Again, I'm just using key and value, the text for my key, the text for my value. And I'm going to go ahead and call producer send and get back the metadata. Now I told this to autocomplete is true, so I give this assert here that the send should automatically complete, and it should complete immediately, so I can check that it's done. I could also see that it's successful. This is a little is_error function, which just does the future to try and do a get. If that get fails, it's either going to return back the value or it's going to throw. Okay, so if this get, it's either going to return back a value or it's going to throw an exception, in which case we'll return true. If we don't get an exception, return back false. It's not an error. And the offset should be 0. Okay, so we get an offset from it. The topic should be the same topic that we wanted. Okay, let's take a quick look at that mock producer code. Again, this is right from the Kafka codebase. Okay, and this is using Kafka 8.2. So you can see here, we could pass in a cluster to it, and we could tell it to autocomplete, or just tell it to autocomplete, and it won't use any cluster. It just have an empty list. Or you could pass in nothing, and it'll automatically do the same thing of autocomplete feature. Some of the things that are nice, right? We saw the send function, but what's nice about it that you could do is you could tell it, it's going to give you the next offset, the partitions, the metrics. Where it starts to help you is you could tell it whether or not to complete the next one. Okay, so you could tell it that you want it to error next. So you could tell it to do a variety of things. So like error the next function. So when you do call and say you're going to send a message, it'll error the very next one. So you could work on your error handling of what happens when the Kafka producer does throw an error. Okay, so this is a mock producer, which could come in handy. Maybe it doesn't fulfill all of your needs, but it's a good start and gives you an idea of how you could mock the producer, and maybe a good, starting ground for what your mock producer may be if you need something slightly different. Now, just like there's a mock producer, there's a mock consumer. You could do some interesting things with it as well. Subscribe to topics, a list of topics. You could poll, so that you want to go and read a message. And in this case, if we looked at this code, it's just going to go ahead and hand back a dummy record. One per topic you're registered for. So a nice little, helper here. You could tell it to commit, all sorts of things, right? To seek to somewhere. It implements that whole consumer interface, except it's not really going anywhere. So now you can put your code in place that uses a mock consumer and allows you to isolate your business logic. Again, this may not have everything you need, but hopefully will give you a good starting point and some good ideas of how you may want to build a mock consumer. So these are at least two of the testing facilities built into Kafka that you could use. And if you want to do more sophisticated stuff with, say, Zookeeper, you'll find that there are in-memory Zookeeper quorums you could use and other things to help you mock the whole environment. So again, these are two ways that you could help test your Kafka code, one with a mock consumer, one with a mock producer. In this segment, we're going to look at monitoring Kafka with two different tools, one the Kafka WebConsole and one the Kafka Manager. They try and do similar things. They don't have the same exact functionality, and they're not both at the same level as far as their currency. So just to point out real quickly, this Yahoo Kafka Manager looks like it gets updated pretty frequently. 3 days ago, 7 days ago, 11 days ago. So pretty active development. And we'll take a look at this tool. And then there's the Kafka WebConsole. This hasn't been updated in a year. Whether you look at their most recent tag, or if you look at their most recent branch, it's pretty old. So Kafka's changed quite a bit in the year. This hasn't been updated in a year. Let's go ahead and still take a look at both of them. And it really is going to be which you feel more comfortable with and which you prefer that you want to use in your environment if you choose to use one of them. They both offer some features that you may find essential or can augment your internal tools. So let's first look at the Kafka Web Console when it comes up. So when it comes up, it knows nothing, right? You have Zookeeper here, and it shows no Zookeepers, and you can register a Zookeeper. Okay, so let's register our first Zookeeper here. We're just going to call this devzk. It's running on my local host. The default port of 2181. There is no root there, and we'll tell it that it's in development, and then we'll connect. Okay, it shows that we're connected, so it's using Zookeeper to discover brokers. Okay, it shows that we have that Zookeeper there, and let's see, it doesn't show in this case. Sometimes it doesn't quite work. It doesn't show brokers. Oh, it shows, there go these topics. Okay, that's our broker, port 992. topics, which Zookeeper is part of. And you could go ahead and just kind of expand a topic. And you click on it. There's no consumers from it right now. There's no topic feeds. So you get some basic information. Okay. The Kafka Manager comes up, and it doesn't know of any cluster. Okay, so the first thing you want to do is you want to go ahead and add a cluster. So we're going to add a cluster. Let's call this dev cluster, Zookeeper. Okay, in our case, it's just localhost. And so we're running the latest version. Okay, and we want to enable JMX polling. It's nice of it to catch that for me. Alright, so it's done. Go to cluster view, and lo and behold, it shows I got 4 topics. I got a broker. You can see I got a bunch of other things that appear here. If I look at the broker, you can see some interesting stats. There's a broker there, the port, JMX port, the bytes in, the bytes out. It has some basic stats on messages in a second, bytes in, bytes out, bytes rejected. So interesting things. If you look at it further, it shows us number of topics. So it starts to show us some more interesting data, and then we could drill into a particular topic. Okay, we could delete it, reassign partitions, we could update the configuration, and we can see how data is flowing. If we want to see this kind of in action, over here I have this Kafka producer performance test. I'm just going to tell it that for that performance topic, how about we go and insert a whole bunch of messages. Okay, so this is just start pushing in a bunch of data, just so we can make sure that, hey, this guy is doing what it says it does. It's going to show us messages a second. Let's give a second refresh, so you can see that the number changes. If we go to this Kafka WebConsole, and go to this perf topic, still don't see any consumers, which there aren't right now, which is fair, and you really don't get a whole lot from it. Go back over here, let's refresh. You can see that we're sending in a bunch of data here. There's our bytes in. Okay, so it's pushing data in. If we then want to say, okay, that's the producer performance, now let's run a consumer performance, and that's going to start to consume from there. Okay, so it's going to complain because it has many threads and we just have one partition, which is okay. And then we can see that this updates. We'd expect the bytes out to start to move as well. Okay, so now the bytes out are moving. So you can get a good idea of how things are performing in your environment just by using this tool. A nice thing, you go into this topic, you can list all the topics, tells you how they're spread out, any sort of skew, replicas, if it's under-replicated. Okay, you can also do something nice too of you want to create a topic. We'll call this my favorite topic. Yeah, we'll get partitions, say 4, replica 5. You can leave the rest of it just completely empty. Okay, it'll default. And there we go. Go to topic view. There's my favorite topic. It's got no data because I haven't written to it yet. And it shows all the partitions and shows everything. So in this segment, we've seen 2 different tools that we could use to monitor Kafka. One's a WebConsole and one is the Kafka Manager. Both of them may have features that you find useful in your environment, and I'll leave it up to you to do that due diligence and figure it out. I think you could see from what we've seen, the Kafka Manager may be a little bit more feature rich at this point, but that doesn't mean that the Kafka Web Console won't catch up or may resume active development. In this segment, we're going to go over using the Kafka Consumer Offset Monitor to be able to monitor how well our consumers are keeping up with the production of data. Okay, so I have the UI up here, haven't started a topic yet, have a topic I created. We're just going to call it offset test. Actually, I already did call it offset test. What I'm going to do is I'm going to start this producer performance test. So this is going to load in a bunch of messages. We'll get that going. Then in this other terminal window here, I'm going to go ahead and I'm going to start the consumer performance test. Okay, so that I'll go ahead and start to consume data as fast as I can. Before we do that, let's go over here, take a look at the topics. And sometimes this application takes a moment to get running. Okay, we have a topic, offset test. Okay, it doesn't show any active consumers. So let's go ahead and start our consumer going. Okay, remember this is a application to monitor the consumers, not the producers. Okay, so start our consumer. Okay, so it shows our consumers. And now it's going to go ahead and put together a graph of that. And sometimes this takes a moment on the first rendering. Let's see if perhaps this speeds it up. Okay, so let's give that a moment while it's generating. While it's generating, one of the things you want to keep in mind, as we discussed in the previous segment, that the level of parallelism is with the partitions, right? It's also your consumers are consuming at offsets from Kafka. And you want to make sure that when you look at the lag, there isn't that much lag or no lag, if possible, between your producers and your consumers. If your consumers are starting to lag significantly behind, well, that's indicative of the fact that you can't keep up and maybe you don't have enough consumers to be able to consume that data from Kafka. Let's see if we could help this out, maybe reduce the load here. See if we cancel. Let's go ahead and cancel that. Okay, let's see if we get, there we go. Okay, so this went ahead and generated. This shows we had all these messages coming in. It's not registering that we were consuming messages, but you can see here in this chart, it shows the lag, it shows the log size, and it shows that we're behind all these messages. Okay, so we're lagging almost 4 million messages. So it really got behind there. So, and here's the log size. So what you're going to want to do is you could use this tool. There may be command line tools you could use, and you're going to want to make sure you're keeping track of how close your consumers are staying with the producers. Maybe hard to keep the offsets right in line where it's no lag at all, but you're going to want to have it somewhat in a comfortable realm if you're trying to keep up with the production of data. Okay, so this is the Kafka Consumer Offset Monitor. And it's one tool that you could use to be able to monitor how well your consumers are keeping up with the production of data.